Hello students, welcome to Sourav Sir's classes. So for classes, mock test, study material, you can contact the given number. So let's start solving one of the problem from JEST Physics. The problem states that a particle of mass m is subjected to a one-dimensional delta function. Potential Vx is given by minus V0 del of x and V0 is greater than 0. So we need to find the bound state energy and the wave function, right? Two things we need to find. One is the bound energy state, and the other is the wave function, right? So this type of problem will help you to clear the concept based on solving the Schrödinger's equation with delta potential, discontinuity in derivative of the wave function, and normalization. So solving this problem, you can proceed to solve this type of problem in your exam. So let's start to solve this problem one of the easiest way. So we have the potential which is given as Vx equal to minus V0 delta of x, where V0 is greater than 0, right? We will solve the time independent Schrödinger's equation. Solving the time independent Schrödinger's equation we have h cut square by 2m into del of psi by del x square equal to minus V0 into del x into psi x, so which will be equal to E of psi of x, right? So for bound states, we have E less than equal to 0. We let E equal to minus h cut square k square by 2m, right? So we have phi x equal to a e to the power minus k into x mod, or k equal to m V0 by h cut square, right? From the discontinuity equation, condition, psi prime 0 plus and psi prime 0 minus equal to minus 2m V0 by h cut square. So and phi 0 will be equal phi 0. Then using phi x equal to a to the power e to the power minus kx, we can write minus ka plus minus of plus ka equal to minus 2m V0 by h cut square into a, or minus 2m V0 by h cut square, or h k equal to mv0 by h cut square, right? So the bound energy we can write E equal to bound energy we can write E equal to minus mv0 square by 2h cut square, and the wave function we can write, so the wave function we can write as phi x equal to root over of k into e to the power k x, or k equal to m v0 by h cut square, right? So these are the bound energy and the wave function as required from the problem. Hope the solution is clear. So thank you.